Good evening, everyone. So I have actually fixed the camera. It was quite simple. I added this camera update function, and instead of doing this in the switch statement right here, we just call it whenever we need to update the camera. And this function takes a camera where if we are having this flag set invalidate previous, then we are just copying the current state of the camera into the previous one. And we can verify this here by printing the camera position translation, to be exact. Oh, oh, I think I might be compiling with optimizations. So let's enable this again. And we can see in the output here, we're having minus 20 here. Earlier, we are having 100. And there's at no point where we're having minus 20 and 100 in the previous one. So that's pretty good. I think that's all I made off stream. So what we will be doing today is that I am having, we don't need to print this. I am not really having any way of measuring how long a frame takes or to make it be a specific length. So the only thing I'm doing right now is I'm sleeping 10 milliseconds or something like this. And then also when I'm drawing, I'm sleeping 15 milliseconds. So if we run it again, I don't know if you can notice on the stream, because I think the stream is only at 30, but this is kind of stuttering. And the reason why it's stuttering, it's not because we are lagging for any particular reason, but for one, sleeping 15 milliseconds, that's not really how you it's not really how you synchronize the frames being drawn. So the entire frame might take, I don't know, 15 milliseconds, 16, 17, 20 milliseconds. We don't really know. And similarly for the game might be running at 100 FPS or maybe 90. We would like to make sure that this is more stable. And then in the OpenGL graphics here, I am assuming all the time that the delta time is halfway in between the previous and current state. So we want this to be an accurate representation. So let's say that we are running the game at, I don't know, let's say 50 frames per second, but we are having an unlocked frame rate. So we're just drawing it as quickly as possible. Let's actually do that right now. So if you're able to see the stuttering, like you might see that it's better, but it still looks like it's updating like slowly compared to what you would expect. It's not as smooth as you would expect for an unlocked frame rate. So that's what we're going to be working on today. Now, the way we do this is we need to have some way to time how long things are taking. And on Windows, I forget what the function is called. Query performance counter. Now, all this we want to kind of abstract. We don't care about the query itself. We just want to have some value that represents, you know, how many microseconds probably that something took. And then we will be adjusting based on that. So let's make another header. And what do we need? We need I32. What is this? Timestep. Okay. This I think we can delete. We need time now. Now I'm thinking, are we going to say that this will always be microseconds? Something like this. Not H. Now this might be an I64 actually. Does Emscripten also do it as a I64? Or maybe U64? It's a float. The current time in milliseconds. So maybe we will just keep that. Now, query performance counter is a U64. Large integer. We need, what do we need? Oops. Profile API. So I think I don't really care about how many microseconds has passed since the start of the program or start of the computer. So I believe we should have the previous count is long. Is it signed? No. Oh. What is it? D or I? Uh-huh. So what's the issue? It's just wrong. It's provided. Oh, maybe I need actually, where am I defining that? In main. Now this one gives me per microseconds. Counts per second. So to get milliseconds out of a second, we just multiply by 1,000. Hmm. I think that's good enough to get started. I don't know. I think something very similar works on Linux, but Emscripten might be a little bit weird because we only have floats. Maybe. Hmm. Let's just use this for now. But I need to figure out how many milliseconds to sleep, which still works. Yeah, I don't know. It might just work out. So yeah, obviously we need to set this up. And add this to the game. So let's just print this out. How do I print a double? Is it the same? I think I can just do 0.3f. Oh. Let's see what we get. Hello, Renes. Hope you're doing good. We're not printing anything. Why is that? Or wait, maybe we are? No. Redefinition of timestamp. Actually, let's. I want to save this somewhere. What is the issue? Time setup. Oh, I need to put this in main. Yep. Okay. The time now is 0 always. Why is that? Let's see what we got. So only the quad part here is important. So we have previous gets the last one, or the current one. Current one gets the one we just measured. We get the delta. It's some number. And then we get a very tiny number. But still measurable. Is it that I can't? Oh, okay. So just when I'm running it normally, am I? Hold on. Am I doing this wrong? Oh, I'm multiplying instead of dividing. So these ones are in per second. So it's not per 10 seconds, it's per 1,000th of a second. So yeah, silly me. Now we should be able to see, yeah, 27, 28. That's still a bit higher than I would expect. I mean, there must be another sleep. Because there's no way it's taking 17 milliseconds. Yeah, this thing. Yeah, that's more what I would expect. Whoa. Now everything's ultra fast. So this is why we need to time this a little bit more, because obviously if the game is running faster, then not only does the physics run faster, or not only does the game update faster, but like that means that the physics run faster as well. And we don't want that. So we need to have a target update rate somewhere. Now, did I already make that somewhere? Sleep time, render frame rate. So this should be something different. This should be a physics rate. And let's see what we need to update with that. What is this? This one I don't think I'm using. I think I actually want to put it in here. I don't strictly need this one. timestamp. I don't know. Yeah. So let's remove this. And same render. Let's remove it. And in game, this should be actually in defines. This is not relevant anymore. Yeah, I disagree. No target architecture. Eh? Is that even a thing? PP hash error. So I guess I have to include Windows.h, and then it doesn't complain. But then this is of course unused, but never mind. What, did it go faster? I guess because of the target frame rate. It's supposed to be 1 over this. Oops. And it should be per second, I think. Because everything is running, like the second is the SI unit. So I don't know if I actually need to think about milliseconds or microseconds. Like I could just say that the delta time is in seconds. Because with a float 64, it's going to be way within the limits anyway. So this count per millisecond is actually just a count per second now. So that should be good. Yes. At least it's running at the same rate now. Now, when I'm printing the time, we can just do like times 1,000. Yeah. So that's good. Now we want to sleep. Right. This is in seconds. So let's see how that goes. Okay, so we have one very fast update and one that is slower. Am I hitting no here? I think I know why, but I need a short break, so I will be right back. All right, welcome back, everyone. So what's happening here is that we are coming here very early, and we're calculating some large number to update, like, I don't know, 30 or something, right? 33 or something like that. So we sleep 30 milliseconds, and then the next time we arrive here, we realize that, oh, we overshot the sleep. So we are not sleeping at all. So it's just running immediately. This is, I don't know if I can pause this. We're sleeping, you know, we're not sleeping. So the entire frame took minus 0.817 milliseconds of our target. Oh, now something is happening. Okay, now we hit a point where we're updating properly, but that's just happenstance, right? So one time we're sleeping and we're overshooting, and then the next time, because we overshot, we are not sleeping at all, and then because we didn't sleep at all, we are sleeping again and overshooting, and so on and so forth. So what we actually need to do here, and I think I realized I want to have two different structures here. So one will be a time settings, and we need to add them, of course. Yeah, we don't need to do that. And in it, we also need so we grab the first timestamp. maybe not even there. Yeah, maybe not even there. We put it in invalid. So here, what I want to do, we do a timestamp, maybe even here. So we sleep first, we get the time now, and then what? We need to know how far we overshot. And maybe I do that here. What should we call it? Synchronize. Mm. maybe because we're having this, right? Does that compile? Yes. So let's just see what happens here. We need to wait 31 milliseconds. So we sleep 32. I want to see what delta t is. $32.8. think this is missing this time. Yes. So we have this value. We take it minus the target. And that's how much we overshot. And we can also get this from this count. Oh, did I wrap? 6.5. Ah, there we go. Yeah, this count 3 to 5 to 70 is the amount of counts that we need to um, adjust this with. To get the accurate beginning again. And then next time we will hit the same. Like we are adjusting our targets with this. So I just need to do that in code in the synchronizer. I don't know what to call everything. So it's I64 delta maybe adjust. No, it was the temp. I think I need more data here. So we are having I64 count begin. Yeah. So I don't really want to have this temp one. So when we first do this, we get the number of counts that we're trying to hit. And I need to cast this to an F64 because otherwise I think this might be just like 0 or something. I don't know which cast has priority. So I'm manually casting it to F64 and then back to I64 actually. So we have the count targets. This is the overshoot. So the count begin is equal to the current minus the overshoot. And maybe we just even do time now. And we will just do time dt minus equal settings target. Yeah, makes sense. And in the game, when we are starting, it would just make a function like this. Timestamp. So we can do this, but then immediately just say t begin equals t current, t delta t equals 0. So I can try to print this here, but I'm assuming that it will just be a very, very low value, like maybe even like tiny. We'll see what happens. Minus 30,000. Well, that makes no sense. Checksum. This time is going to be humongous. 11 seconds. I need a quick toilet break, so just give me a second. Right. So this is actually where we want to stop, right? So where are we? Well, with this time now, we need to get the delta. We don't need this previous one. Overshot by millions of things. Oh, I'm dumb. Hey, pancakes. I don't have any commands like that. See, this is the problem. I need this delta before I subtract the target. And I guess we can also add this assertion, overshoot. Or actually, no, because you don't know. Maybe we didn't overshoot. If we didn't overshoot, then I guess we're on time. I still want this to be on a different line, though. So yeah, now we have count begin, count current, the target. Now that might just be the first one, right? No, there's something else. We are having this many counts per second. Oh. It's trying to do 30 seconds. Yeah, count per second divided by seconds per count target gives us the target count. That's some basic uh, analysis of the units you can do. Okay. So we never hit it. Current begin 34. Count target is this. So we get a good overshoot, like 10K. That's reasonable. So we say that the beginning is the current one minus the overshoot. That's good. Our delta time, which is currently at 34, 35, not target. Now that looks good. So why are we never hitting it again? It's just growing. Delta time is seconds. So why? $9 million seems a bit high. And that makes sense because we're never actually changing the begin. I guess if we overshot, I need to get the overshooting, right? So we do this outside now. We don't, even if we overshoot, we do that in the synchronizer. Because the synchronizer's job is to synchronize no matter what. So now the effect of that is also that we are always updating the begin frame. Actually, we always do this, even if it's negative, because then we just add the overshoot. So now you can see here that this is the time after the sleep, and it can vary a bit because you don't know if the sleep is going to come back immediately or after 100 microseconds or even like up to a millisecond. That's fine. But I would like to have a way of knowing how long did it actually take. So the time it actually took, we can find out by doing this. It's the same as this one. And this delta is this. return that. Okay. So now we are hovering around the 33 to 34 millisecond mark. But the next time we arrive is it should be very much stable. Like the delta between frames should be exactly the same. And the benefit is that in here, not in game run, oh, and actually, I don't think this should be in game run at all. I realized just now. We should put this in the forget what the name was. Is it really in WinMain? No. We are running window loop, and window loop is running. Wait. Aha. Okay. So we do the okay. Never mind then. I was thinking this was the game physics update, but it wasn't. We are already pushing all of the data to OpenGL before we do the mutex and then synchronize. So that's good. Now I do want to copy probably the time as well, because I need to know the start in OpenGL. So we are going to game header. This is our main time for the game loop, but we're also doing oh, right. So I don't really need the time now. I'm gonna do that in the graphics loop because I don't know when I'm gonna arrive, but I will copy. Where do I copy it? This we don't need anymore. Yeah. So now in OpenGL, instead of getting the DT like this, we can do, well, I need the header. And this is not delta t. This is like from 0 to 1. So we can do normalized or something. Time dt divided by time. No, time settings. Target. Yeah, target. Hold on. Isn't this target? Not threads. Time setup. This is 30. But DT target. I think I had a brain fart. Let's do this just to fix whatever bugs I introduced with that. This is not DT target. This is okay. I was thinking like, why am I having this inverse all everywhere? But I was supposed to have this from the beginning. Okay. And then just fix these. And finally, get this back so we can actually, can I just edit? No, it didn't happen. Okay, moment of truth. Oh, that is smooth. You see that? That is very smooth. Now you can still see that this is overshooting by a little bit. And the way we fix that is to, instead of doing this, we don't do that, right? But then we need to yield in a loop or something. So like we can do so this delta milliseconds, it's always floored and not a do while, just while. Or maybe so now we need to do the same thing, right? We update the time. We can get the delta t equals left to wait. It's much better to just have very verbose names in these situations. So left to wait in seconds, by the way. So while left to wait is larger equal to 0, or actually just larger than 0, a double. We do thread yield and another time now, and then another left to wait. So maybe a do while would be like clearer here, but I don't necessarily want to yield before doing anything else. So yeah, if we run this now, it should be much closer to 33 milliseconds. Oh, no. Or it can just crash. Okay. Why is that? Did I make a mistake? Well, obviously, but so this is positive 333,394. 333. Okay, cool. So we yield and then we do it again. Now what do we got? Well, left to wait. Oh, I see. I just got it backwards. Yeah. Oh, it's so smooth though. I'm so happy with that. If you saw the beginning of the stream, you would have seen how choppy it looked like. Now it's still overshooting sometimes. Let's do something more extreme. Let's just spin loop. No? Like it's more rare. I feel like okay. Let's do this right. Oh, or actually. Like this. So if we have more than 2 milliseconds to wait, then we wait for whatever number minus 1. So if it's 2, then we just wait 1, so on. Yes, that's what I would expect. So now we're like right bang on the money. Let's try adding the yield again because we don't really want to spin loop. That might be just what I need. So let's check the performance of this. Well, it's pretty high. Although something is wrong with my task manager. That's pretty high. What if I remove this again? So yeah, don't pay attention to the CPU value. Just look at the like relative. Now I don't know why it does this. I have a open hardware monitor or not. I checked it with this. I think it's just like some kind of Windows bug. But it happened to me like twice now. Where did it go? Here. I don't know if I can make this larger. I don't think so. But yeah, if we look at CPU, well, right now it's like 50% simply because I'm streaming. Although I'm surprised. I'm surprised the stream isn't drawing more. Okay. So anyway, actually I might be spinning on graphics. That's why. Yeah, you can see my CPU total is like 10, 15, 20%. And here it's always 100. So like whatever is below, it just adds up to 100. And I don't know why. It happened multiple times. I think it's like some program or driver that I'm using causes Task Manager to mess up. And it happened multiple times. So it's not a virus or like, it's definitely not something running in the background that I'm not aware about. Yeah, anyway. Now if we run it, so yeah, it's choppier again because we're not spinning on drawing. We didn't unlock the graphics. I don't know how fast the graphics are drawing right now. But yeah, the CPU total 20, 28. And now you can see it's like down here 6%. So it's like, that's what I would expect, basically. And it's spending 95% of the physics loop just sleeping and yielding. But yeah. I don't know. Can I get away with this? No, I can't. This might be better, actually. Yeah. So then we just have to do something similar on graphics to measure it, right? Or actually, no. So I think graphics, it will just be either VSynced or not. Or is there a benefit to locking it? See, the thing is, we can lock it in software. I don't know if that actually makes sense. So if you play a game, you can VSync, and then it VSyncs to your monitor settings. So it's in the code. We go to OpenGL, we draw, blah blah blah, and at the very end, we do this swap buffers. And I haven't looked it up, but I'm fairly sure it's the same. If we enable VSync with a like GL enable something, GL enable VSync. Where I have to do this. VGL interval. Um, I mean, how do I do it? One. Let's try that. So init. So if we're on Windows, we do that, blah, blah, blah. So when you go into a game and you click on the settings to enable VSync, like that's the call. If it's using OpenGL, there's similar calls for Vulkan and DirectX. And all it does is that when you're calling this function here, swap buffers, it doesn't return until after the the frame has been drawn and the thread has waited for the next frame to be ready to be uploaded. And that's based on your monitor refresh rate. So if we do that, now it should be updating at 60. I don't have a way of telling, but you can see that my application is like 2% right now. And it's running pretty smoothly. Now, I don't know if it's running at 60 or 144 hertz. But, you know, we can also, ooh, interesting. I also want to try just before I finish. Disable debug. Okay. And now it's running optimized. So actually the game feels slower now, but I think I was just running it way too fast before. And again, yeah, we can see that the CPU total, oh, it's pretty high. What happened? Oh, it's not me, it's Firefox doing something. Or maybe this is counting the compilation step. I'm not sure. But the point is now it's smooth and efficient. So much better than before. So everything that we've done was worth it with multi-threading. Well, actually, I didn't implement the multi-threads on, I didn't implement the worker threads yet. Yeah. Now I can actually synchronize the threads, which is very good. All right. That's going to be it for today. Synchronization or time complete. So thank you very much for watching, and I'll see you next time.